Okay, welcome everyone to our education session for today, Tuesday, August 25th. Tomislav, the floor is yours.
Hey, hello. So for today, I was thinking to talk about some changes that I did on the client.js page. So I want to start from there. It's related to comment that Don Connolly created on my repo, related to this one function that is doing the HTTP requests. And his comment was about basically if I'm using this inside this function, this helper function to create HTTP requests, I'm using fetch, which is directly function from DOM, so from browser DOM. And of course, this is not very good, because how can you test this function if you always need to have fetch in your scope? So this means this fetch is somewhere else. It's not in the scope of this function. It must be somewhere in the outer scope of this function. And this is basically what we want to do when we are working with object capabilities, or even lower level, just by looking at the functions and the parameters. So what this Dan's comment and what I did to refactor the code is to extract this dependency as a parameter. So now the same function is not using the fetch directly from outer scope somewhere, but it's this function is parameter to the function where this HTTP helper function is created. And what this means? This means we cannot just expose or export or all our function or our helper function that are using this rnode HTTP, but we need to create parameters for all of the hierarchy of the calls of the function. And I want to relate this to my examples in Scala, when I was talking about how we are extracting direct instances and creating this as a parameter. I want to connect these two things because they are completely the same. We are using the same logic, or the same way how we are extracting this free variable, or this fetch, which is not mentioned in the arguments, but is in the outer scope. Is this make sense so far?
Yes, well, I'm following, that's that similarity of, abstraction. So, with what you did with the Scala code, abstracting it away. So I'm interested to get a better understanding of how those concepts of extraction that you apply to the Scala it can also be transferred over to the HTTP fetch abstraction. So I'm looking forward to your explanation.
Okay, cool. So basically what I did here is, instead of using fetch directly here and just like coming from nowhere, because it's not mentioned anywhere else. It's just part of the JavaScript environment where you execute in your code. And in the new version, I'm expecting that this function will be supplied, and then it can be used here. So this means that you don't have rnode HTTP directly. You first need to get this fetch function from somewhere, so you can create this rnode HTTP wrapper. And I want to show how this extracting the parameter is like bubbling up to the start of application, because now every call to this function must be parameterized with this new parameter. So now we don't just get the wrapper for rnode. We need to supply this additional dependencies, and this is what like complicates things, because now everything is pushed to the start of the application, and the start of application is this index file, where now all the DOM dependencies are extracted here with the fetch function, with a log as I'm renaming the log to original because I'm changing how where it's displayed, and also not just in the log, but just in the console, but also in the page, and the warn function from the console also. So now, to get this rnode wrapper to make HTTP calls, we need to supply this fetch from the browser. So now the situation is clear. We're only using fetch from the browser here, and our instance for rnode for rnode client, we can mock, and we can supply different fetch for testing, and this is not directly related to DOM. And I created like multiple functions for each for each level where we are creating some wrapper around HTTP calls. Because first we want to have a wrapper around fetch. Then when we have this tiny wrapper, then we want to create another wrapper which is using this rnode web and additional log and warn console operations, which can also now be supplied differently in testing. And now when we have this bigger object, which contains effects for our web application, then we can supply this whole effect object together with, again, log and warn, because we want to log something to our complete application, the rest of UI. So here are all of the effects, and now I will go to. Can I go here directly? Oh, nice. Now the UI can accept the element where will be rendered, and all of the effects that are used in application. Just for this start, I'm extracting warn to write that the Ethereum library is available on the page, which means MetaMask is available. And all the other effects are going to the start of application. So our initial state, together with these effects, and effects are like DOM operation or this fetch, log, or this kind of stuff, or whatever we have in the DOM. So we are accepting all of the DOM events, all of the DOM dependencies, and our UI is completely clean without any side effects. I must say that this is not completely true, because Ethereum connection is still using directly. So here, for example, I'm using directly this Ethereum wrapper for MetaMask. So I just want to say that this is not completely true, but the idea is that now all of our controls accepting this state that I was explaining in previous sessions, and this new object which is effects. And these effects in the main control are basically all of the helper functions to create rnode requests and response. To check the balance, transfer, send, deploy, propose, and these two functions directly from DOM to display log and warnings. So, I mean, do you see how now all of the dependencies to UI are in the parameter of the function? This is basically what I'm explaining now. I didn't do anything special, right? I just extracted whatever I use inside the function to be available as a parameter. And now I can...
Same abstraction. That was the same. That's the same abstraction that you were doing in Scala. Now you're doing it here. That was the.
Yes, yes, and now I can show this in Scala code where on the we have it's in Scala it's a little different where because we are using I mean it's just different objects, right? We are what we are using here is like almost like identical like a DOM, right? So here we are saying, oh, we are using these instances for list and option. And now when we are calling this filter A, this is basically using these instances that we imported inside this function. So with these two imports, we are importing something that is not available in the function. We are importing something that is in the outer scope. So this is very similar how this rnode HTTP is using this fetch from outer scope of the function. So we want to extract this fetch and push as another parameter here, so we can basically refer only to parameter and not something outside the function. And this is exactly how this result type is extracted. So now in this example, we are saying that this this instance for let me just remind myself, for we are using traverse filter as before, so we just extracted the result result object, and now this applicative is becoming a parameter from which this filter A can or more, not filter A, but is not F, is depending on applicative, and now is not F, is using this parameter applicative to get like dependency. So instead this import, we have this additional parameter to the function where we're saying, oh, but this is not F, is using this dependency for you know, whatever implementation will be supplied, this is not F will use this implementation, not a concrete implementation where as we used here. So this is a connection to this code where here we are using fetch directly, and here, sorry. And here we extracted this as a parameter to use it directly. So in JavaScript, we cannot do any more complicated type level thing like in Scala, because in Scala we can supply parameter on the type level. So we can say, yeah, but you know, this is not directly parameter to a function, but it's some kind of type level thing that we can decorate our function and say, yeah, this doesn't have to be directly as a parameter. I mean, especially this is true for Scala, where Scala gives us this way of implicit argument that I was explaining, that we don't need to supply this argument all the time. This parameter can be somewhere in the scope, and then it can be automatically supplied to the function. I hope this part makes sense.
So, let me repeat it back as I understand it. So, with the Scala that you have here, so you have your function that your abstract function where you can call all specific parameters, but you have one function that's outside of the scope, and you have to import that. And when you're importing it, in order to make it part of the abstracted features, you have this implicit applicative in order for it to be part of this import to be part of the parameter. That function and capability in Scala, comparing that to JavaScript. So in JavaScript, where you have features, which is outside of the scope, or not feature, when you have fetch, so fetch is outside of the scope, and you need to import it. Do you have something similar to implicit applicative in JavaScript, where you can bring in the fetch?
Yeah, in JavaScript we don't have any way of specifying this as a type.
Okay.
So the only way is just to create another parameter, because all parameters are the same. When you look at these parameters that we have to this function,
okay,
you don't basically know which type are these parameters. You cannot say, oh, this is a URL and must be string or something like that.
Okay.
So all the things is dynamic. Yeah.
So we have fetch outside of the scope. And it's outside the scope. It's not one of our parameters, but in order to bring it in, we import it, and when we import it, we have to create a new parameter for the fetch and for it to function properly.
Yes.
Okay.
And now when this is a parameter to a function, then basically when we want to create another version of this function, we can supply whatever we want here. We can supply directly fetch as previous, or maybe some other our version of fetch for testing, or which is not doing the real work.
Yeah, that was interesting. You mentioned that earlier. So apparently you can have you can have different types of fetch. You know, one for testing and one for something else. Is that a new capability? Did you not have that ability to use a testing fetch before? Is this give you additional flexibility?
Yes. That was exactly the point of Dan's comment here.
Okay.
Because I was not very careful, you know, how I'm building this. You know, I was just creating this like quick example that you know, and I was using fetch directly. So yeah. If you want to be like completely correct, then you should not use DOM from everywhere. You know, you should only use DOM from specific place where maybe you can use this more secure version of JavaScript. You know, so that you can say my whole UI is not depending on anything. You know, only on the input parameters, so that you know you can control how you can say that it's safe, right? Because you can supply your own fetch, for example, that can only get to some specific URL, right?
Okay, well, I guess in that, so having this test fetch capability that gets down to the core. Now I have a better understanding of what Dan's comments were, why he wanted to see this refactoring. So okay, so this was helpful.
So it's basically object capability model. If you put the fetch in the routine, that's an ambient capability. That's like taking that it could do anything and destroy anything. Whereas if you're in control of what the function can do, that's supporting the capability model, and it's just a much safer way of programming.
Yes, and now we can ask another question. For example, what is this JSON? Right? Someone can say, yeah, but you are using JSON here. What is this? Right? This is some ambient object, right? How I get this JSON here? This is also not correct, right? We can also say, yeah, maybe you want to stringify JSON to supply also to the function, because this is also an effect.
So, but you know what JSON is in scope here, and the JSON doesn't access anything outside of the data.
Yeah. I mean, I'm just saying, where is the border between, what should be parameter to the function and what is okay to use? Because I'm using this Lambda library here also. So if this is like pure function, then we can say, yes, you can just use it from outer scope. But as Jim said, if this is doing some I'm not sure how to characterize if this is connecting to something or doing some effects. I'm saying effects because
it's something external. If it's dealing with anything external, then you've got a hole in your code that can be dangerous. But if this JSON is all internal, if it's a library that doesn't touch anything outside of the data that's in this function, then it's okay.
What would you say if I'm calling eval here?
If you're calling what?
Eval. Eval.
Eval. Well, that would be a problem.
Yeah, I mean, it's not that this is like external thing, but it's dangerous. It's just dangerous, right?
But in eval, there externals it invokes an external process.
Yes, I mean JSON is also some kind of external. So I'm not completely sure, how we can split this and say what is what we need to extract, what not. I mean, definitely, if you're doing something external or dangerous, then you want to extract this, and but I'm not completely sure exactly what parameters that we want to extract.
Well, I mean, if the fetch operation didn't, get something from the outside world, I would have no problem with it. I mean, I don't see how it would benefit us to extract it.
But as Dan pointed out, you cannot easily test with this fetch function, because this fetch function is always doing HTTP request, and maybe you just want to check the parameters to the fetch. So you don't want to execute, or maybe you just want to return some mock object. So from that perspective, even the JSON you want to have as a parameter to stringify JSON. because you can say, yeah, but I want to supply my own stringify function. So
if you have the fetch outside of the scope, then the JSON perhaps needs to be outside of the scope as well.
I mean, yeah, you can say that you know, this code is still not completely pure because you want to have this stringify function also as a parameter.
Right, right.
So where is that imported?
Import for what?
JSON.
Oh, JSON is also on the window. This is JSON object on the window. In the same way, how is fetch on the window object? So they are both on the window object. I mean, on the window is also the console. So all of these objects are on the window, on the DOM, right? On the browser DOM. So it makes sense that we abstract all of these objects or functions as a parameter. But I want to say that when we are doing this, we are creating lots of parameters to our functions. So on one side, yes, we want to extract everything, but now when we look at the start of the application in this index file, now our start of the application must accept all of our like effects or whatever dependencies that we have. So if we want to be completely correct, our application will, you know, as input parameter will have all of the functions that we need from the DOM or outside, or for example, maybe I mean, you can also ask and say, okay, but you are using in address here, you are using some operations on like the crypto stuff for calculating rev address and from private key, public key. Is this also effect? Because this is something that it's also like external. So maybe we want to abstract all of these parameters and say, yes, this is also parameter to our UI. Because this is not part of UI. This is external thing. So I want to say, like both sides, we are extracting this as a parameter, which is what we want, easier for testing. We can apply object capability rules, but on the another side, we have a bunch of parameters that we need to handle, and we need to handle this through our code all the time. So we are supplying this from the start or from the root of the application, and then to each control. For example, in this control, we have on add account. So all of this. All of these effects are wrapped here, so that they can be supplied to each control. So now UI is much cleaner because each control accepts only what is using. So here, address control can only add a save account, add account, right? The balance can only check the balance. It doesn't have ability to call anything else. I mean, in JavaScript, definitely this is not completely true because you still have your window and everything. But if you want to be like correct and call only from parameters, you can call only these supplied functions. So in our UI, we can you know, just by looking at the parameters, we know what this part of UI, what it can do. You know. So now our UI cannot create just any HTTP request, or you know, it's very constrained on what it can do. And this is what complicates applications, right? I mean, our engine let me make it bigger. Here is our dependency when we are, for example, this is our dependency when we are transitioning from one state to another in rnode. So we have all of these parameters are basically these are all dependencies that we have in rnode, so that it can work, right, with all of this stuff. So we need to carry all of these parameters on multiple places when we are transitioning, when we are using these functions. So whenever we are creating when we are calling one function from another, we need to repeat all of these arguments and say, oh, I'm depending on all of these arguments. So when I call this function is also depending on all of these parameters, right? So each of our engine, and we have multiple engines like initializing, running. I don't know if Casper Launch is also an engine, or just the helper function. But when we are creating or using this engine objects, we need to supply all of these parameters. So what I want to show is we are using the same thing, right? We are extracting the parameters, and we are saying, okay, these are not concrete implementations, but these are parameters to our function, and we can create different implementations that that we want to use, when we are constructing the whole application. But just for this function or this class, we are specifying what are the parameters. So basically, in each case, we are doing the same thing. We are extracting what we are using inside the function. We are extracting as a parameter. That's the main thing that I want to show. It's not anything complicated, right? It's extracting the parameter. I mean, I can show on the. So here is just JavaScript example. So, for example, if I have function for just summing two numbers, right? That doesn't. It's not important what this function is doing, but so if I have another function that is saying plus 100, and we can have one argument and say, oh, now I'm using this first function, and I'm saying whatever I have here as x, and another parameter is 100 because I'm doing plus 100. And now we can say yes, but this function depends on this previous function. So this function, we can say it's not pure. This function is pure because we are only using input arguments. We are not using something else. But this function is not pure because we are using something that is outside of the function itself. So what will be the correct way? I mean, I'm not saying correct way because it depends on the context, right? It's not wrong to write this kind of function. If we are depending on something else, this is completely okay. But if this plus is in some larger scope or in some another library, then it's becoming a problem. And especially if this is not the pure function. So we cannot say, oh, this function will always behave the same. So we can maybe create plus 100, which is pure, and we can say yes, but first you need to give me this implementation of this plus function, and then this another argument, And then we can use this plus implementation, whatever we have, and do the same thing. So we extracted this plus function in another argument to supply. So we cannot use it directly as the first one. So result 1 can be plus 100, and this can be 1. And in another example, for the pure, we will first supply our plus function, and then as a second argument, we can supply our argument that we are calculating. And let me write this down. R1, R2. So now we have both of the results, right? They're correct. So this is basically the same principle in all of these cases.
Hey, Tomislav, I mean, some of this looks a little bit like dependency injection, but do we have a dependency injection framework that we're using with Scala in the RChain code?
So you know that usually when we are talking about dependency injection, we basically are saying, oh, partially applied functions or carry functions, and this is exactly what I'm showing. So yes,
okay,
you're right.
We're not using a library for it, right? We're just using the fundamental.
So we are using this tagless final style to and this implicit arguments as our dependency injection.
Okay.
So, yes.
Okay, cool. Thanks.
And in Scala, this helps us to not supply all of these arguments all the time. So, for example, we have all of these parameters specified with the Scala syntax and the syntax sugar in this way. And when we are calling this class, when we are calling this class, we only specifying one level of parameters, right? Only this stuff. And this stuff is written in this style of implicit with this colon and the name. So now I was explaining how this is another syntax for implicit, right? So when we are using this class, now I'm pressing Shift and Control P, and now we can see what other arguments will be supplied to this function. So this is not visible. So you see that all of this stuff is also supplied, and we can do this manually to this creation, to this constructor of this initializing. So in JavaScript, we don't have this ability. So we need to supply all of these parameters to each call of the function. And in Scala, or maybe as Artur mentioned, we can have a dependency injection, which can hide part of this stuff and keep this in the scope and apply without our manually specifying this. So this is like different way how we are trying to escape to write all of the parameters all the time. Because if we want to be completely correct, we need to specify all the parameters in each call of the function. And you see how this can be very large. How much parameters can be supplied for each call. So instead of supplying all of the parameters, we can say what dependency that we have, and these parameters will be managed by Scala runtime. they will Scala will move these parameters for us. So we don't we don't write it down.
So in JavaScript, we could create an object which each component of the object is a parameter. And then we could have 100 parameters, but we would just need to pass the parent object to all our routines, you know?
Yes, yes. So you see here how in this main control, this is input to UI. This is the root of all controls. And I have only one effects object. And in this effects object, I have these functions. So, where this main control is used? In start of the application in index. And here, this is how this effects object is created. So I'm not specifying each property, but I'm saying, okay, all of the create another object which has all of the fields from this up node F together with these two functions. And this is exactly the same here. So this is part of the up node F object, and this is additional two functions. Jimmy, does this make sense? This is exactly what you said, right? You're transferring this as one object, and you can combine additional stuff to this object. You can, just like I did here. From this one object, I'm combining with this another two functions to another object.
All right.
This is
I never saw the ... in JavaScript before.
Yes, this is, you can use ... or spread operator on objects and or arrays.
All right.
So if you have object A with one property, and if we have, so if we create another object with B, we can spread the first object and combine both of them in one. And basically we will copy all of the fields from A to this new object. In the same way how this works in Rholang for map or for arrays. So yeah, I mean, anything that can help not to write all the parameters over and over again, it's useful. But it's also
works in Scala too.
In Scala.
Yeah.
Yes, but in more limited way. I'm not aware of that exists. But for example, this kind of syntax can supply.
Right.
So this is a list, and it will supply this as parameters.
Okay.
So yes, so there is something, but not. In JavaScript, you have more options because you don't have types, so everything goes.
And both are in Scala, in Rholang, but a little bit different, right?
Yes, a little bit different. Yeah. You can spread I mean, in JavaScript, you can also do some strange things with function arguments. So with the new standard, you can use ... But previously how can I show this easily? With our plus function, maybe. Where is my? So here our plus function accepts 2 arguments. Oops. So we can call plus in this way. With apply, we can say, so this is not important here. And here we can say our arguments in this style. So for this kind of syntax, we can write now with ... So let me check that this works. Okay, yes. So in this style, we are applying whatever this parameter will be this inside the body of inside the body of plus. So we can supply whatever we want to have, like our context, this, and as array we can supply arguments to function. Right? Not just like. So this is like polyadic style. We are supplying. This is not a tuple, but it's like 2 arguments. This is confusing in most of the languages, right? Because these are two arguments to a function. It's not a tuple, but it's 2 arguments. And in JavaScript, we have this way of calling the function in different way where we can supply all the arguments as array. So basically, we can create dynamically our arguments to our function. I'm not sure how if you see this first time in JavaScript, this is very confusing because this looks someone made this up and say, yeah, we will have this apply function that you can call on any function and supply arguments in this way and call this function in this way. And this is not all. There is another way to call it with call, and in this style, I think we need to supply 1 argument after the another. Yes. So there is another way how to call a JavaScript function, and with the newer syntax, I'm not sure if I will do this correctly. I think we can. Well, with ... we can say ...
This is sort of like xargs in Unix, isn't it?
Yes, you're right. We're transforming this from like a tuple of arguments to an array, although this is not the real tuple. But here you can see. Oh, I will just print args, and so when we are calling this with 1, 2, 3, we will see array of 1, 2, 3. Oh, come on. Oh, yeah, I cannot do this. And now we have array of 1, 2, 3. And of course, I can put as many arguments as I like, and they will all be in array. So if I'm using this style here, I can supply these arguments whatever arguments I have here, or maybe I can say, yeah, not the first one, but all the other. So now we are summing 2 and 3, and we will forget the first one, right? Because here we extracted the first argument, and what is the rest will be array, which we'll supply here. And now I'm thinking, can I do something like this? Right? That would be nice. And yes, this works also. Right? So here is spreading, taking the arguments with the spread operator, and it will combine all the rest of the arguments in arg variable. And now I'm extracting the arg variable, this array, into the tuple of arguments. This is like JavaScript magic. Oh, we are over the hour. Does anyone have any questions about that? Or maybe just to confirm what you heard?
Well, I guess the usual question is, you can do all these things, but which is the best practice?
Yeah. Whatever is readable. Yeah. Yeah. I mean, yeah, we are writing code for developers, not for the machines. That's you know, we should keep that in mind. We can translate everything to machine in some way, but if this is understandable for us, then you know that is probably the right way. For example, in this code, I was I was using this format off, format on, because if you don't have format on and off, then automatic. Oh, I need to remove these comments also. But Scala, what we have now in like auto formatter, will create all of this in one line, everything in one line. And so I created these comments just to split this in multiple lines to be more readable. So to answer your question, it's basically the same thing as in one line, but if it is more readable, then I think it's like you know, easier to understand, and you know, some other developer can read the code and do some changes. And so I'm looking always in from this perspective. Because what I showed today is we are just creating parameters to a function and assigning names. So basically this is all what we have. We have names and we have parameters. This is lambda calculus, so we don't have anything else. All these classes, objects, this is just additional stuff that doesn't give us anything special, right? I mean, it gives us some way of you know, constructing things, on you know, putting things together. But all of this stuff will always have some input parameters that we are using in some scope, and you know, basically all the time we have functions with parameters. So how can we create these parameters in some understandable way? This is like you know, how I see programming. And different languages are given different ways of how to specify these parameters or how not to specify. And you know, I think that's the basic difference learning different languages, to understand how to do parameters in this new language. that's all that I have for today. I hope I showed something interesting.
Yep. Thanks.
Yeah. And I learned something, and I learned that modern JavaScript is something I need to bone up on. It's
Yeah, be careful.
Yeah.
I'm not saying that learning all of the JavaScript is super useful, or but yeah.
All right.
Okay, I will stop recording.